There are special cases or special angle pair relationships that occur when parallel lines are cut by a transversal. The corresponding angles, so 1 and 2, 7 and 8, 3 in relation to 4, 5 in relation to 6, they are congruent, each pair. So angle 1 is congruent to angle 2, and angle 7 is congruent to angle 8. And all 4 of those are congruent to one another because 1 and 7 are vertical, and so are 2 and 8. You also have alternate interior angles that are congruent. Angle 7 and 2 are congruent to one another. Angle 5 is congruent to angle 4. The alternate exterior angles are also congruent. Angle 1 is congruent to angle 8. Angle 3 is congruent to angle 6. And then the same side interior angles are supplementary. So the measure of angle 2 plus the measure of angle 5 would add up to equal 180. Same with the measurement of angle 4 and the measurement of angle 7. They would add up to equal 180 degrees because they're supplementary. These special cases can be further explained using transformations of reflections and translations. First, let's look at reflections. If we have this line A that cuts angles 3 and 5 directly in half, and we reflect angle 1 across line A, it forms angle 7. And when angle 7 is reflected over line A, it forms angle 1. Therefore, angle 1 is congruent to angle 7 by a reflection, which also proves that vertical angles are congruent. Similarly, line B cuts angle 4 and 6 in half. And when angle 2 is reflected across line B, it forms angle 8. And if angle 8 is reflected over line B, it forms angle 2, making angle 2 and angle 8 congruent to one another. If we instead drew lines in this direction, line C cuts angles 1 and 7 in half. And when we reflect angle 3 over line C, it forms angle 5. Similarly, when angle 5 is reflected across line C, it will form angle 3. So therefore, angle 3 is congruent to angle 5. With line D, it cuts angles 2 and 8 directly in half. And when angle 4 is reflected over line D, it forms angle 6. And when angle 6 is reflected over line D, it forms angle 4, making angle 4 and angle 6 congruent to one another. Now let's look at how translations can be used to name congruent angles. First, we have line M, and it's parallel to line L. If we were to translate line M y units down, it will overlap with line L eventually, just like it shows down here. And if line M is then translated x units to the left, all of the angles that are formed by lines M and N will overlap with all the angles formed by lines L and N. This will make angle 1 congruent to angle 7, congruent to angle 2, and angle 8. It will also make angle 3 congruent to angle 5, and which is congruent to angle 4, which is congruent to angle 6. The translations also work if line L, which was originally down here in this lower part, gets translated up and to the right so that it overlaps with line M. We still get the same sets of angles that are congruent to one another. Angle 1 is congruent to angle 7, which is congruent to angle 2, which is congruent to angle 8. And angle 3 is congruent to angle 5, which is congruent to angle 4, which is congruent to angle 6.